Welcome back to our series on applied regression analysis. I'm Mark Ledbetter, and this is lecture video number 19. So this is the last of our chapter 5 videos. This is going to be a little longer video because it's a tutorial for people who don't remember or haven't had exposure to R, especially the R Markdown document that I'm in now. So you're going to be able to find your version of this on Moodle right under the video, or right under the worksheet that goes with the video. Okay, so instead of, so this will, what you're going to do with this file will act as your lecture notes. You can just turn in the file that you modify as you follow along with this video. Okay, so first thing, I want you to look over here in the environment, over to the right top. You notice there's a lot of things here. There are two ways to get rid of everything in here. One is to come up to the broom and clear objects from the workspace. Okay, so we can do that. That will clear everything. The other way is to do it with code. Now, this is an R Markdown document. It's not just an R file. It's very different. It's saved as a RMD, if you can see up here in the file name. I have another file open, but really we're just worried about the one that this tab. So .rmd, R Markdown file is what that stands for. Okay. So when you do this, make sure that you change the title to what you're doing. So if you use this for homework in the future, which you probably will, then you need to change this to say that it's that homework. Change the author to you, so when I open it up, I know it's you. Yes, I know it's in your file, but and change it to the date that you do it, or that it's due. I don't care which. I'm not going to use that date. That's for you. And then I've put PDF at the top here for the output. This document is an RMD document, and what that means is we can do something called knitting. You can see the ball of knitting ball here with the knitting pin in it. And we can, if we click the drop-down arrow, we can knit to HTML. That's not what you want to do. You want to do PDF. Okay, so PDF is what you want to do, and you can do Word if you want, but I still need you to turn it in as a PDF file, the results, so I can grade them when you're doing your homework. Okay. So, but you can export it to Word, work on it, modify it in Word a little bit, and then do a print to PDF if that's what you want. So in white is where we can write text. And in these grayed out areas, they're called chunks. The chunks of code, they're grayed. That's where we write the R code. If you write R code outside of that, it'll crash because unless you use very specific notation, it won't know that you're talking about R coding. It's looking for text. So either it'll crash or it'll just print it as just regular text, one of the two. So to create a chunk, we have to use the little key above the tab key on your keyboard here. And we do 3 of these, and then we use a curly Q bracket, and you see how it just went gray. To end that's how we start a chunk. To end the chunk, you hit that same key 3 times, and now you see that there's white space between those 2 grayed out areas. We have to put the letter R, little letter R, to let it know that we're wanting to use the program R. Okay, it can use different programming languages here, but that's advanced, and we're not going to. All right, I believe it can use Python and some others as well. Okay. So after R, if you want to give it a name for this chunk, we could. But if you start giving names, make sure that each chunk is a specific and unique name. Otherwise, it will not knit. It will give you an error, and it will tell you that there's a duplicate. I'm going to do something down here. Okay. So let me get rid of that. Now, we can also use a comma and put some options in here. I could say message, oops, if I can spell message, equals. Once I equals, and I could say false. You can look at a R cheat sheet for this. I believe it's up under, I think it's under Tools and or Help. It's under Help. Here's Cheat Sheets. That's right. So you can look at the R Markdown cheat sheet and the R Markdown reference guide. All right, those will help you. Now, we can write code in here. I'm going to delete this one because we already have it. The first chunk that needs to be here is the options chunk. This sets up and lets R know how to deal with everything that comes after. So I've named this setup, and include equals false. I will tell you that means that this chunk of code doesn't show up in the output. All right. I don't want it to show up in the output. I put include equals false. All the other code, I haven't done that. So these are some knitter options, chunk, set, right? And so this is tidy equals true. This is very helpful. If you type code that just keeps on going, it wraps. Well, if you can see that it wraps, but let's say we do the, actually let's go to here, find the place where it pops up. There we go. So what will happen is if you say false here, it will print to here, and then this part gets cut off. So that's what the tidy equals true does for us. It wraps the code in when it's printed, which makes it nice and tidy, right? And then echo equals true means that we want to include the output in the output of the chunks, the results of the code, in our final document, which of course we do want to do in general. Okay, you can turn it off for a specific chunk if you don't want that chunk's results. Maybe you're doing something for yourself and you don't want to include the chunk or its output. Then you can say echo equals false. The output won't go there. You can say include equals false, and then the chunk of code won't show up either. Okay, so this is very important. The next thing we need to do is get our data in. And again, if you're going to name the chunks, I've named this data 1. Why? Because if later on I want to put another data in there, I may forget that I have a data already, and I may just name it data. But if this one's 1 and that one's data, it's okay. They're different, and it won't stop my compiling or knitting at the end. So here I am going to I'm going to put the data in a nice format so it can be read by R. And here's how I did that. So how you can do this. I created it from scratch. You don't want to do that. You want to modify this code here, this document that I've given you. You want to modify it, clean it up, and just put what's needed for the homework that'll be due the next time. Okay. So I will give you an Excel file with the data, and that will be put up near the top. You'll see a folder with data up in your general top of your Moodle page. And so what I did was I took this and I copied it. And then I come over to my R and I get rid of the data that's already in there. And then I paste. And now you're going to see a bunch of X's. There's a bunch of errors. What's going on? Well, we need to put commas between things. Now I'm going to select all of these rows, and I want to line them up and make it look nice like it did before. So I'm hitting the Tab key until I get close. And there it is. All right, so everything on this first column is lined up nicely. So now I need to put commas between so it knows where one number starts and another number stops. And you see how the red went away when I did that. So now I do this, put commas in there, and I put commas behind all of them, except the last one. If I put a comma here, it may or may not show up as an error. It didn't show up as an error, but it won't run. I'm going to try to run it, and it won't let me because this comma says there's another number coming, and there's not. Okay, so now, how did I just try to run this down here? It doesn't matter where I am. Here is df1. It's this whole thing. This is df1, standing for data frame, which is not yet a data frame. It's a matrix to start out. I made it a matrix. And I've got 3 columns, and I've got 2, 4, 6, 8, 10, 11 rows. And I need to specify one or the other. So in this case, since I want 3 columns, I'm going to specify in_col equals 3. So if you put a bigger data set in here and there's more columns, you need to change this to the correct number of columns. We do want it to say by row, because we want to enter this number and this number and this number all in one row. We don't want this number, and this number to go up and down in one column. And that is what will happen if you say false there. It'll be a mess. Now, if I have a parenthesis, I want you to notice that when I go outside the parenthesis, notice that up here, the corresponding parenthesis highlights, shades. And so if I move up to this one, I have to be to the right of it. If I go to the left of it, it doesn't show up. So to the right of it, the corresponding parenthesis highlights. So now, in order to run code, I can just run a little part of code. So I could run, let's say, this code right here, just by highlighting it and hitting Control Enter. Okay, and then it would just run that. In this case, once I get to okay, so this symbol is like an arrow. It means assign whatever is here to this object, and you should have gotten that from your R tutorial that you went through, that course. Okay, I want to show you some shortcuts. So if I want that this arrow here, I don't have to type those 2 symbols. I can hit Alt and the minus sign, at least on a Windows keyboard, and I think it is for a Mac as well, Alt and minus sign, but they may have different names. Then I get that automatically. So that's a lot easier than typing those 2 symbols, one of which requires the Shift key to get the arrow, right, or the less than sign. Okay. So anywhere in here, if I hold down the Control key and hit Enter, it runs that. Okay. And now I have what we call commented out df1. df1's commented out with this pound sign. So if I run this, so my point here was earlier, let me back up, is that you don't have to highlight this whole thing to run it. You can be anywhere in here and you can run it. And now I want to see what it is. But if I leave this pound sign in front, then that's just a comment, and I hit Control Enter, nothing happens. Okay, it does the, actually it does, it did the next line, it did not do this line because it's a comment. It ran the next line, it didn't run the line I wanted, which was this line. But if I do this, nothing happens. But if I highlight this part behind a comment, now I can run just that. And what it does is it it prints out what I just put in there, df1. Now I'm going to move this. You see the arrow change to a four arrows there. I'm going to move it up so I can see. And so since I'm going to start over, I'm going to do this. And then I'm going to just show what df1 looks like. There's no column names. That's how it looks after we've run the first time. So now we run and assign column names to it, and you'll want to change these to make them the same as whatever your data is, okay? And if there's more, let's say there's 4, then you put a comma, and then you need to put them in quotation marks, etc. All right, so you'll modify this code to make it fit what you want to do. Now, once I do the column names, then again I can print this out, and now I have the column names up at the top. And now I'm going to make it data frame, which is easier to use. So now I do that, and I want to print it out, and this I do want in the output. And now look how it looks. So it has output it in the code. All right. So when I had just this and I ran this, it puts it out both in the console down here and in the document itself. Okay. Then I added column names. I took a look at it. I see that. Now I make it a data frame, and sometimes it does that. And then I print out the data frame, and now I have these nice white and shaded rows, and here I can go and see that. And there, so it's 10 rows at a time, so there's 16. So I go to the next one for the last one, or for 11. I'm sorry. There's 10 rows. There's 11 rows total. All right, it's just the number 16 I saw. Now I'm going to create this other object and print it out just so you see what's in there, not much. And I'm going to remove this in the end. So now I have two values over here in my global environment. So I can either clear them here, or what I was saying earlier and didn't finish, I think, is that I have this line of code up here in the setup chunk, and this gets rid of everything. Now the next one I've commented out, it will remove hidden objects as well. You may not want to do that in all cases, so what I normally use is this code here. I put it in all the start of my things. That way, if there's something that I've named using other code, it doesn't stick around and maybe get used because there's an error in the code I'm writing, and I don't pick it up because I didn't clear out all of my objects from the previous programming. Okay, so I do that programmatically. All right, so I'm going to get rid of this. We don't need this. It was just to show, just to have a few, I remember what I was going to do. So let's run this again. And I want to demonstrate that if you, over here in your environment, if you click on df1, it opens up that object. So that's data frame 1. And it's nice. You can see, you can sort it if you want by individuals or age. So you can sort it different ways. But values, I'm clicking on that, nothing's happening. So values you have to print out in order to see, because if this goes beyond over here, you won't see it. If there's more than 3 or 4 characters here, it's going to keep going and it gets cut off and you can't see what's over there. Okay. So now I'm going to get rid of this, and I'm going to clear everything again. I'm going to run this. You notice that my console goes down, so I pull it back up. I'm going to run this next chunk of code. I don't know if you're seeing what I'm doing. I've got the mouse over here, and I put it on the arrow, and that runs current chunk. If I go to this one, this runs all the chunks above it, but not this one, just so you know. It'll run everything above it, but not this current chunk. And then you can run the current chunk here. All right. So I've run this. This is what I want. Here's my data, dry weight, log dry weight. These are chick weights, chickens, baby chickens, and how many days old they are, their age in days. So let's plot this by day or age, and I've put the plot function in here. I'm not going to go over this. What you can do is come over to help, and you can type in this function plot, P-O-L-T. And as you do this, you'll notice that this pops up over here. And so you select that, and here's the help file on this. If you still don't understand it, Google it, and it will help you. Now, what I've done in here is I've called this splot, even though it looks like splot. I've called it splot, and that's just because it's a simple plot. Now, you'll have to change, if you change the data set, you'll have to change all the variables. One of the easiest way to do that is, let's say that I want to change age to days. Then I'm going to hit Control and then F. You can also go up under, is it Edit? Yeah, Edit and Find. You see I've got the shortcut keys turned on so I can see them. And then age pops up here, and let's say I want to change it to days. And so then I could say, I can go to the next one, and I can go through one at a time and replace, or if I hit replace, it's going to take me to the next one. I'm going to undo that. So when it changes, when you change the variable names, you can use this find and replace to do that very quickly so you're not typing a lot of things and making some typos. Okay, so you can just use this find and replace and do it quickly. Okay, I'm going to leave it here because I've already run it and I don't want to change it. All right, so this plot, again, you'll need to update when you change your data set and the problems. Main is the title that goes at the top. Let me run this chunk. So at the top you see chick weights by age. And X label, that's XLab is X label. You'll see that it's down here. Y lab is the Y label. Here, dry weight in ounces. And I've got some things commented out here. So if you look at this and look at the picture that's in your book for problem 1, you'll see that it's a little different. That in the book, they went up to 3 in the y-axis and they went over to 20 in the x-axis. So R will do this automatically unless you tell it what the limits are for x and y. Now, to uncomment, to comment or to uncomment, first let me comment this line. I hit Control, Shift, and C. So in that order, Control, then Shift, then C, it comments. If I want to uncomment it, Control, Shift, C. It will uncomment the line you're on. Notice it doesn't get rid of this comment over here. You have to do that manually. So now I want to uncomment these next 2 lines. Now notice that I don't have the whole things selected, but R just requires that you have a little bit selected. So if I had this to here and I hit Control Shift C, it undoes both of them, or it will redo both of them. So I'm going to undo them. And now you'll see the X pop up because I have a comma at the end of here. So I need to get rid of that comment. So you can see I was prepared for this. And now when I run this, this picture does look like what's in the book. Okay? It looks very similar, except these aren't solid dots, but that's okay. All right. So, and ours is even a little prettier because I've got ounces here and I've got a title and they don't. Now, does this look like a straight line? And the answer is no. Now, I have put in commented the code to put the least squares regression line on this. So if I uncomment this, now I can't just run this. If I run this, nothing really happens. Okay, and then when I run that, it gives you an error. You have to run all of this together. This is okay, but this ab line, this adds to the plot, and if you run it separately, it doesn't know what plot to add it to. So I can do it like this, or I could just run the whole chunk and it's fine. And that's what a straight line through this looks like. Does it have a general linear shape? I mean, does it increase and go upwards as x increases? Yes, it does. Could we fit a line to this? Yes, we could. Should we fit a line to this? No. This is curved. So we can look at this though, and we can see that this looks like it's an exponential distribution, doesn't it? It goes and then curves upward. So if it's an exponential distribution, I could take the log of it. Okay, so I'm going to comment these back out, and I'm going to rerun this to the way the book has it. All right. So since it looks like an exponential, we're going to try log base e. In R, log, L-O-G, is base e. Okay? And I've changed my x and y limits to match what's in the book here for that one. So I'm going to run this chunk. And that looks pretty straight. Is it perfect? No. There's a little bit of curvature here, but you know, just curves down a little bit here, curves back up a little bit here, but it's a lot closer to a straight line now. It looks pretty close. So you'll notice that the log 10 is what the book gave you and what the data set here gives you. So let's see if it looks any different. Not really. It looks about the same, doesn't it? I mean, that and this are the same. What's different here is your values will be different in the y because you're using log e, base e, instead of log base 10. So this is a little different. Okay. And again, I made these limits the same as what was in the book. Okay, so this looks like a straight line. So let's proceed with this. But notice that I labeled this over here with the log, and I labeled the top as log. Don't forget that you're not in the original units. You're no longer in ounces, you're in log ounces. So, and I'm sorry this video is taking so long. Both look the same. Since the book and the person I copied this from on the internet, since they both use log base 10, we will too. So we're going to take a look at this regression equation. Y equals beta naught plus beta 1 x plus e, our epsilon. Okay, so you'll notice here that this is in what's called LaTeX code. You can use it in Microsoft Editor too, Microsoft Word Editor. Or it's not just Word, it works in PowerPoint, Excel, anywhere they do equations. So I'm not expecting you to do this uniquely, but you can keep what I have and you can modify it. So if you need, once we get to multiple regression, you'll need beta 2 x2. You can copy this and add the terms and make sure that you look. So when you hover your mouse over it, it shows you what it's supposed to compile as when you knit it. Okay, so we should not do this, but the book did it, and I want to do this just as a teaching example only, but we should not analyze this way. Once we see that a straight line is not a straight line, we get rid of that and we go only with a straight line. But let's take a look to see what would happen. So LM1 stands for linear model. So LM is a linear model function. Notice that we have our y here, and we have distributed as, which is our little tilde there. And then we have over here, whoops, don't want to do that. Then we have age, our x value. Okay, so very similar to what we have here. Instead of an equals, we have y, and then we have the x value, which is age. And then we need to tell it what data to pull from, and we're going to tell it data frame 1, or df1. And then we print the summary of this. So if I run this, and now I'm just going to print what LM1 looks like. Let's see what it looks like. Not very much. It gives us the coefficients. So here's the intercept, and here's our x value. This is beta naught, and this is beta 1. So the summary gives you a lot more. Now this is not anywhere near as pretty as the SAS output that's in the book, is it? The SAS costs you at least, I think, $2,500 or $3,500 a year for every person that uses it. I think it's $5,000 for an individual, and this costs exactly 0. So yeah, it's a little messier. I think we'll all deal with that, not to have to pay for it. Okay, so here it gives you the formula, what your code that you called. Here it gives something called residuals that we talked about, and so this is the smallest residual, the first quartile, the median residual, third quartile residual, and the max residual. Okay. And the coefficients. So here's our estimate. So that means that this is beta naught. Our intercept is beta naught. This is beta 1. And here's the standard error of the estimate. And so that is like the standard deviation of beta naught here. And this is the standard deviation of beta 1. And then the corresponding t-value, remember that it has n-2 degrees of freedom. There are 11 values, and it says 9 degrees of freedom. Of course, later this will change. When we get to multiple, it will be not the t, it will be the f or something else, or chi-squared. Okay. And then here's the probability that we're greater than the absolute value of t. So we're doing that test, h naught, beta naught is not equal to 0. That's a two-sided test. Here's the probability that under the null hypothesis that we would get this value, that the intercept beta, if beta naught is 0. Under that, if that's true, the probability that we would get this estimate is only this. It's very small. The smaller these p-values are here, the probabilities, the more we say we want to reject the null hypothesis. Okay? The smaller, the more significant. So usually our cutoff is like 0.05. This is 0.005859 if we round it to 4 decimal places. This is 0.0006. So way less than 0.05. And here's the significance codes. 3 is that it's, let's see, let me make sure. Yep, so this goes in front of 0.001. This goes with 0.01. Notice that this is greater than 0.001 but less than 0.01, this value. And then a 1 is when it's significant at 0.05, a dot is when it's at 0.1, and empty would be that it's not significant at any of those. And almost no one uses an alpha that's greater than 0.1. Then we have the residual standard error, okay, with 9 degrees of freedom. We have something called the multiple R squared that we'll talk about in chapter 6. We have an F statistic that we'll talk about in a few chapters, and the p-value. And you'll notice right now that this p-value here is really close to this p-value here. In fact, it's the same one. This just has one more decimal place, and this one's rounded. This is the test here, okay, that the model is significant. And remember, for a straight line, if the beta 1 is significant, that says that a straight line is statistically significant. The model is significant. Here, this F statistic is used when we have more than one predictor, when it's multiple regression. Okay. So now let's talk about the intercept. And you'll notice I have in dollar signs all of this. So I have beta not hat is equal to, and you see I pulled this value here, negative right here. The regression analysis yields a test statistic. Here's my t-value that goes with that one. We're just talking about the intercept. And the degrees of freedom, n minus 2, there was 11. So yeah, so when I hover over this, you see what's going to show up when it's net. And corresponding to a p-value of approximately 0.0059. That's this one here. Indicating, now this is the important part, is the conclusion. I gave you a sentence, use that sentence. There does exist sufficient evidence to support the claim that the intercept is different from or not equal to 0 at a, in this case it was a 95% confidence level. That's our standard thing unless the question says something different. So here I don't have a question, so I just went with that. I don't remember if in our book it tells us, yes, it does say 95%, so we use 95% all the way through. The slope, here's the test for the slope. We give the value of the test statistic, we give the value of the estimate, which is beta 1 hat here, and again that comes from this second line here. So we're going to look at that second line, and we give them the test statistic, the t-value, and we give them 9 degrees of freedom. Here, I was reminding you that we were at 9 degrees of freedom. When we're writing this up, we would just write 9. We don't need to give them the calculation. And then here's the p-value. Rounded to 4 decimal places, we do that as well. So imitate what I'm doing here when you turn in the homework. That's what I want. And so here there does again exist sufficient evidence to support the claim that the age of the chick, which is the x value, helps to predict the chick weight, the y value, at a 95% confidence level. I think my sentence said something about the sample size, but if you have degrees of freedom, then you don't have to include the sample size in that for that part. Okay, but we know that there was a really distinct curve on this graph, but even with that curve, look at what happened if we had not looked at our, I'm on 128, if we had not looked at our initial plot here, and we just performed the analysis, we'd say everything's great, there's a straight line relationship because everything's significant. Our p-value is really small here, and our p-value, yeah, so this says that the straight line model is significant. This saying our intercept intercept is significant as well, and that's all wrong. It's not linear. So we're going to use the log 10 of the dry weight, log base 10 of the dry weight that was in the data set. So now we're changing, and notice instead of LM1, I'm changing to LM2. So LM1 is still out there. I'm not getting rid of it in case I need to use it for something else. And then I'm taking, now my Y is instead of dry weight, it's log dry weight. And the X stays as age. And again, I do a summary, and here's the summary of that. By the way, if you want to get rid of the output, here's the X, clear the output, and I'm going to run the chunk again. All right. So here it is with the log, which is what we should use. Now, I want to remind you that when you're in the log, you're not in the original unit, so be careful with what you say. Don't just say the intercept is this and say it's in ounces. No, it's in log ounces. Okay, so the Y is now in log of ounces. So we look at the intercept, which is again this line here. Now look how small the p-value is. It was small before, but now it's got 14 zeros, 13 zeros in front of this 1 here. So small. And the same thing here, it's tiny, so it's very significant. And we have our output. So let's look at the intercept again. It's going to be very similar, except that we get this. So all of this is going to be the same, except that we're changing our test statistic value. We're changing our estimate value because it changed, and our p-value. But it is significant, so there does exist sufficient evidence. The slope, again, we're just changing the numbers. It's still significant, so there does exist sufficient evidence to support the claim that this helps predict. Now I changed it to log base 10 of the chick weight. That's very important. Let your reader know that you're no longer in the units, you're in a different unit. And so I do say here that we notice that the R squared, adjusted R squared, is 0.9981 for this model, and for the previous model it was 0.7158. Higher is better. The higher it is, the better the model fits the data, and the better it is at predicting the response variable. This will come in chapter 6. So let's do the confidence intervals for beta naught and for beta 1. And so here is the command, and here is the output here. So for the intercept, this is the 95% confidence interval for beta naught, and this below it is the 95% confidence interval for x1, which is age. And so we would write out the 95% confidence interval for beta naught and write it in interval notation. Okay. All right, well, this video is very long, so I want to move along a little bit. And we have this confidence interval here for this. Let's find the confidence intervals for the mean and for 7 days old. Okay, and so here's the code for it. We run it, and we get, here's the y hat value. Here's our lower estimate for that point, around the mean at that point. So this is the confidence interval, not a prediction interval, but a confidence interval for that point. Okay, and so I've written it up here. Take a look at how this looks, and so I write it in confidence interval notation, and then, but who understands log ounces? I don't, not conceptually. So we're going to transform these back. So this is something that you probably don't need in the future unless you've taken the log of something. And since it's log base 10, I'm doing the reverse, so I'm raising 10 to the power of this value. And so this prints it back out in the right units. So, and then I say what I've said before. Now this here is how we can run our code in the white space. We put one of those, and then we have to put R, and then we could put the R code that we want to run, and then another one of those to close it out. Okay, I don't do that very much. It's just as easy for me to use the dollar signs or just to put the value. Okay, and then I write the confidence interval in ounces, and here it is. And you could take a look at what day 7 looked like, and here was the in ounces 0.052, and this confidence interval doesn't even go that high. It's a little low. So this point is actually out of the confidence interval for the mean. So interesting. As straight of a line as it looks, this point is a little outside of the confidence interval. Now let's talk about the prediction interval for a single value of x naught. So here we had, let's go back. Here we have interval is confidence, and here I have interval is prediction. Just about everything else is the same. And here's the, we'll run the code. And so here's that, and it knocked that console out again, so I'll pull that back up. And so this is the log base 10 of the drive weight, and then we can transform these back just like before. And so here that is. And now let's talk about the confidence bands. This is something that certainly I would want you to know how to do. So use this code, modify it as you need. Here's for the log 10, and that's what we're going to do. Is this is what we plot, because it doesn't work for the non-log 10 for these confidence bands. Okay, so let's run this. And here's the confidence band for these chick weights. Notice that the points 6 and 7 are actually, the center of those points are actually outside of the confidence band. And we know that this, even though point number 2 is as well, but it looks like it's right on it. So it's very close, okay? Very close to the upper limit there. Look how narrow those are. Very narrow confidence bands. Hard to see the curve, but there is a curve here. It gets narrower, which is why this point near the mean fell out. Okay, and so this means that our straight line assumption might not be valid. Even as straight as it looks, it might not be valid, and we'll find out in chapter 14, so much later. Now let's talk about prediction bands. So everything's almost the same, except now we have the prediction in here instead of the confidence for that point. We run this, and now we get the prediction bands. Look how much wider they are. None of the points are falling out of this, so as we would expect. Okay, so, and when we did the prediction band for the individual point, and we transformed it back, we got from 0409 to 0566. So 052 is in there now for the individual. So it is in this range. I also want to mention real quickly before I close that even though I told this to round to 4 decimal places, it does significant digits. Okay, significant digits not. So this 0 here throws it off. I say that, but then why did this one not do it? So it's a little inconsistent. In fact, it has a dot there instead of a comma. So that's kind of strange. Let me make sure that yep, it's still got the dot. So that means that there is, oh, I know what's happening. This is the 0 for here. I'll fix the code so there'll be a comma in between there. I forgot the comma. Okay, so that's covered everything that we've talked about in the chapter basically. And this is good code. Again, it'll be cleaned up before you get it, that one little spot. If you have questions, let me know. I'm happy to help you. And this, your completed file where you've typed in the code, because your file didn't have it, that is due by midnight of the day, and that will be your lecture notes for this lecture. And until next time, take care.